Jetzt, wie könnte es anders sein mit KI weiter? Scaling of Closed Loop AI. Ich bin sehr gespannt. Der Vortrag wird von Alvaro Canizares gehalten von der Firma Siemens. And I guess it's in English or Deutsch? Yeah? Okay, good.
All right. Good afternoon, everyone. I would like to start my presentation with one number. 100 terabytes of data per hour. That's the amount of data that we collect with our install base from the shop floor. It's just to give you a glimpse of the amount of data that is being generated in the shop floor and the amount of potential that is there to actually leverage this data and turn it into something that generates business value. Oops. And obviously, artificial intelligence is one of the tools that we have now and manufacturing industries have now to actually leverage the data. We as Siemens, but also our customers, are already using AI to improve manufacturing processes with the data that they are collecting. But often, they struggle to go from a POC phase to an actual productive AI solution that generates value over long term in their factories. My name is Alvaro Canizares. I'm team lead for our projects team for industrial AI portfolio, and I work for Siemens Digital Industries. And in the next few minutes, I want to explain you what is our experience on how to scale AI in the shop floor. Before I deep dive into AI specifics, I just want to go a step back. So what do we see that is driving customers to actually implement AI in the industry? There are global trends. We all know about them. Decarbonization, energy efficiency, resource efficiency. These are only some of them. And this, in the end, was setting the corporate strategies at our customers to actually start changing these trends and being, for example, more energy efficient in their factories. And this is also now what's pushing AI adoption. It's one more technology that industries have to actually try to improve this kind of KPIs and implement the change that we need, for example, a sustainability goal. And now I want to share with you a customer example, so a specific AI use case. It was a project about monocrystalline silicon ingot production. This kind of product is what you see in the picture. So it's a big cylindrical block with a very pointy part, very characteristic. It's a raw material that is used for a lot of electronic components and solar panels. And the production process is quite challenging. So it's also what gives this characteristic shape. You have basically a vertical oven with highly purified silicon melted at high temperature. And in a rod, you place a crystal. You have to keep rotating this rod and move it vertically along this molten silicon to actually grow that crystal into the product that you see in the screen. That's why it's also that pointy. And this process is quite challenging to control based on a lot of handwritten control strategies and adjustments. It depends also on operator experience, and it's quite hard to control and have the required quality that you need for this kind of product. And this customer applied AI to solve this problem or improve the quality of this product in their production. How did they do it? They developed an AI model, an AI solution that improves the control of the heating. So like I said, it's an oven, so you have to control the gradient of the temperature, and they use AI for that. And that already returns some value to the customer. For example, improve growth speed of this ingot in the oven. Now, this sounds very good, but this is applied to one oven. In these factories, you have dozens and hundreds of ovens. So how do you scale from a POC that has now been successfully applied to one oven to actually apply this AI solution to all the ovens across your factories and also across different sites? And I want to go back to this concept. So in your company, if you start doing AI or you want to apply AI, you will have a lot of great ideas and potential use cases where you want to apply AI to solve that trouble. But only some of them will actually make it to a productive AI solution that you can run in a productive environment, because there are specific requirements and it's quite challenging to do so. What have we seen with our experience that are the biggest challenges when you try to develop an AI use case in a company? So like I said, you will start with a lot of great AI use cases, and here we have tried in a simplified way to visualize the amount of success that you will have, in different use cases across the time and effort that you will spend. And there are 4 big challenges: the data challenge, model training and validation, a scalable infrastructure, and closed-loop AI. What happens? You start with a lot of ideas. To develop a model, you need data. You need an historic data set. Only for some use cases, you will actually manage to have all the data that you need to actually develop a model. So some of use cases, you already will have to stop or put on hold because you don't have enough data. Then you go to the next phase, model training and validation. You need to train the model, you need to validate. Already a few of these models will show the performance that you need to actually have return on investment, If you have managed to do so, you want to take that model and run it close to the line. You want to start using the output of this model and see how it behaves in an actual production environment. So you need an infrastructure where you run this model. And in the end, you want to also use the outputs of this model productively in your environment. You want to connect the model predictions to some quality database or whatever you have in your use case. So that's the other challenge. And what we have seen in our experience is that most use cases fail in the last 2 steps, because you can train a model, validate it, let's say, in an offline environment, in a cloud or in a PC. But then it's quite challenging to actually run it in a production environment where you need to collect live data from the line. You need to also write back somewhere with some diverse protocols that you usually find in the shop floor, with low latency and specifically robustness that you need to run in such environments. There is also another way to see these challenges. It's where is actually most of the business value being generated by an AI solution. And it's not coincidence that it's actually in the last 2 steps. It's the last 2 steps that are harder, because if you manage to go through the last 2 steps, means you have connected your AI solution and you have integrated the AI model predictions to your already existing production processes, and you're actually generating value, improving some process with the AI solution. So that's why when you start developing an AI use case, data challenge, model training and validation is nice, POC, okay, it's a potential use case, but you actually will turn the business case behind that AI model green if you can actually scale that model, that oven optimization model, not to one oven, but to several ones. Then the business calculations looks very different. And this is exactly what I want to share with you today. So how we can actually make that scaling faster. How can we support our customers and our own Siemens factories to actually apply AI at scale in a productive environment? When you develop an AI solution, there are usually 2 main phases. You need to build a model, and then you need to run it. So you have this kind of 8 or infinity symbol. The left circle represents the build cycle, so you need to build your AI model. The right circle represents the run and monitor. So that's when the model is running, for example, in your line. And it's connected, and it's an infinity loop, because once you deploy a model, it's like any other solution or system, you need to monitor how it behaves over time. Models are trained once with historical data, for example, and maybe the performance will degrade over time because production changes happen in a line, in a running business. And for example, you need to monitor when the model is behaving different or worse and trigger a retraining. So it's this kind of, you have to go through all these phases, build and run, several times while you are actually running an AI solution in your factory. And there's also another perspective to this cycle. Usually on the left, in the build cycle, you have data scientists and machine learning engineers who are building the model itself. But then the model is deployed on the shop floor, where you don't have data scientists and usually software developers. You have automation engineers who have to actually configure this model and connect it to PLC in and outputs. So what we are doing, or we set ourselves as mission, is to build an infrastructure that supports industries to bring their models from the cloud, which is usually where they are developed, to the shop floor, and enable data scientists and automation engineers to be efficient in all the steps that you need to build and run a model. And that portfolio that we are developing now to support these machine learning operations for the industries is called Industrial AI. It's a set of applications that will support you when trying to deploy these models, and it's based on the Industrial Edge infrastructure. Industrial Edge is the industrial IoT platform from Siemens Digital Industries, and it's built on 3 levels. So you have the cloud. You have the cloud on the top left. We have our Industrial Edge hub. For example, you buy their Industrial Edge and have your account, can purchase apps, for example. Then 1 level lower, in the middle, you have the Industrial Edge management. This is like a central server that is usually located in one of your factories and will take a role of central management, for example, to distribute apps and install it in a target device, or handle security updates and have an overview of all the edge devices that are running in your factory. That's the bottom layer. That's the field level. That's where you have edge devices that are actually running their industrial edge apps, and when you can implement Industry 4.0 use cases, for example, AI use cases. Yeah? As industrial edge devices, we have a whole portfolio of edge-enabled devices, for example, industrial PCs on the bottom left, HMIs that are already edge-enabled, and you can also use your virtual infrastructure to actually deploy virtual edge devices where you can run this kind of applications. And based on this distributed architecture that is, by the way, needed in the industry because it's not so easy to connect the control layer, yeah, where the edge devices are, with the cloud. There's no direct connection. So you need this distributed IT/OT architecture to actually make this connection and bridge the gap between cloud and shop floor in a safe way and robust way, which is what the industry needs. So based on this infrastructure, we have developed our industrial AI portfolio. It starts on the cloud. So usually data scientists, they want to work in their own environment. They work, for example, in the cloud environment is where they work on AWS, Azure, or whatever cloud environment. And for example, they program their Python code to train the model. After they have validated also in this cloud environment, we give them the AI SDK, the AI Software Development Kit, which is a set of Python libraries that enables them to standardize the model in and outputs, model definition, and wrap the model in a standard way so that that model can be deployed at any site, at any factory that is based on Industrial Edge. 1 level lower, at the Industrial Edge management, at the factory, we have the AI Model Manager. This allows you to pull those AI models that are edge-ready into a central server in your factory and distribute them to all the target devices where you need to run those models. It could be 1, it could be 10 lines in the same factory that are using the same kind of model. And that's how you distribute this model to the edge device. There is where we have another application. It's called AI Inference Server. It's a standard runtime, Python runtime to run those AI edge-ready models, and where you can connect via UI, for example, in and outputs that your model needs. For example, some PLC signals, or to connect the output of the model to some database where you might have to store for quality purposes. But like I said, it's not only writing back to some process. Over time, your model needs to be, it's a solution in the end, an AI solution. Your model needs to be monitored to see if everything is running properly over time. And that's why, again, at the edge management level, we have the AI Model Monitor, which allows you to collect all the metrics that you need to collect to be able to say if your AI solution is actually working as expected all the time, and you can monitor. And you can also take all those metrics and upload them to the cloud, which is usually where a more refined monitoring strategy is happening. And when there, it can be decided if the model actually needs retraining or not. And then with these applications from cloud to shop floor, you cross that loop of machine learning operations where the model is built and where the model is run, with a clear mission that we want to drive down costs and efforts of our customers to deploy models in the shop floor. So they don't have to code their own infrastructure to run models in the shop floor, but they can use the standardized infrastructure to enable them to run different kinds of AI use cases with the same set of apps and without the need of having to code, but just to configure all these applications, so that also an automation engineer can access and leverage the potential of AI in the manufacturing industry. So finally, from my side, your key takeaways. So if you want to start with AI or have started, you have to identify the right AI use cases. Always have the business potential in mind, a return on investment ready, because you have to validate if your AI solution actually is generating value for you. And there are already a lot of kind of domains like AI vision or process optimization where AI can be used. If you use a standard infrastructure, you can lower down costs and efforts in your project, which will help you also to achieve that return on investment faster. And the key phase or the key challenge that you have to actually solve is to be able to write back the results of the AI model to some other system or integrate, because that's how you're generating most of the value in your line. And that's what we mean with closed-loop AI, that you're actually using the AI model results into your factories and into your integrated processes. So you can come visit us. We're in Hall B6. You can try to find me, otherwise ask around, and I would be willing to show you more in detail how these applications look like and how they run. Thanks a lot, and maybe if we have some minutes, we can do some Q&A. Thank you.
Yeah.